Hello, welcome. In this short video, let us look at the relation between the binomial distribution and the Poisson distribution. Basically, we want to look at the derivation that leads from binomial distribution to Poisson distribution. That is, we want to look for the proof of limit as n tends to infinity. The binomial distribution pkn of k should equal or reach pk of k, where pk of k is the Poisson distribution. So that is, we want to prove that limit as n tends to infinity binomial distribution with the parameters n comma alpha should reach the Poisson distribution with the parameter alpha. So we know that the definition of binomial distribution is given by n choose k alpha divided by n power k 1 minus alpha by n power n minus k, where alpha by n is a probability value and k is equal to 0, 1, 2 and so on. And this value, that is the binomial distribution, is 0 for all the real values of k that are not equal to the whole numbers. Let us start with the left hand side of this theorem. Basically, limit as n tends to infinity, we have the definition of n choose k, which is given by n into n minus 1 into n minus 2 and so on up to n minus k plus 1. This is nothing but n factorial by n minus k factorial, and divided by, we have n power k. So note that there are same number of terms in both the numerator and the denominator here. And then we have alpha over k divided by the k factorial from this n choose k. So we have k factorial, and then we have 1 minus alpha by n power n minus k. By dividing each of the factors with one of the n's from n power k, we have limit n tends to infinity 1 times 1 minus 1 by n into 1 minus 2 by n and so on up to 1 minus k minus 1 by n. And we also have alpha power k divided by k factorial, which is basically independent of this limit, and then we have 1 minus alpha by n power n divided by 1 minus alpha by n power k. So if you actually insert the value that n is equal to infinity, we basically get that this factor is equal to 1, and this is actually independent of n, and this value is basically equal to 1, since 1 by infinity is 0 and 1 minus 0 is still 1 and 1 power k is 1. And then we have the limit. Let us write that 1 times alpha power k by k factorial multiplied by limit n tends to infinity 1 minus alpha by n power n into 1 by 1. So this is equal to, and this limit is by definition equal to e power minus alpha. We know that e power minus alpha is equal to limit n tends to infinity 1 minus alpha by n power n. So we have finally the limit n tends to infinity, the binomial distribution basically becomes e power minus alpha into alpha power k divided by k factorial, which is nothing but the Poisson distribution. Thanks for watching.